so now we're going to talk about how to find the derivatives of logs. Okay, so again, I want you to have your notes printed out, and you can just fill this in as we go along. But let's do these examples. So here's the first one. All right, f of x is equal to 3 times the natural log of 2x. Okay, so whenever you want to take a derivative of a natural log, okay, if there's a number in front, you're not going to worry about it. Now, if there's x in front, which we'll do in a minute, that's a whole different ball game. But if there's just a number in front, just leave it and go ahead and make it as a fraction, 3 over 1. Because you're going to multiply it by the derivative of this thing. Okay, so to take a derivative of a natural log, it's super easy. You're going to draw a fraction bar. Whatever is behind the natural log goes on the bottom, and then the derivative of the bottom goes on the top. So what is the derivative of 2x? It is 2. Now, you can simplify this, so like these 2's would cancel. So if I multiply straight across the top, then I get 3, and straight across the bottom, I get x. So there's my derivative. Okay, derivatives of e's and derivatives of logs were really easy. All right, so let's do this one. F of x is equal to the natural log of 2x squared plus 4. All right, so when I take the derivative, all right, there's nothing in front of this one like there was before, so there's nothing to put in front. I'm just going to draw my fraction bar. Okay, so remember, whatever's behind the ln goes on the bottom, and then the derivative of the bottom goes on the top. Well, the derivative of 2x squared is 4x, and the derivative of 4 is 0, so that's all I've got. Now, I need to see if I can reduce it. Well, if you look, I have 3 terms, and what do they all 3 share in common? Well, I can knock everybody out by 2. So my derivative would be 2x over x squared plus 2. You want to always reduce whenever you can. All right, so then I gave you a note, and it says, all right, if you got an x in the front, whenever you have an x in the natural log of x, just like with e's, you got to use a product rule. All right, so let's do this one, x times the natural log of x. Okay. All right, so we're going to separate these. So the first one is an x, and the second one is a natural log of x. Now, you can't ever just have a natural log on its own. It's always the natural log of something. So that natural log of x is stuck together. But there's my 1, and this is my 2. So when I do my my product rule, sorry, it's a 1 d2 plus a 2 d1. All right, so let's fill it in. 1 is x. All right, now d2. So I need to take the derivative of the natural log of x. Or don't let me confuse you. See, don't you see that as a squared or anything? All right, so my 2 is natural log of x. So again, draw my fraction bar. Whatever's behind the ln goes on the bottom, and the derivative of that goes on the top. All right, plus 2, which is the natural log of x. All right, d1, well, the derivative of x is 1. So if I think about this, this is kind of x over 1. So if I reduced it, those x's knock out. I simplified it, so I'm just left with a 1 here, and then natural log of x times 1 is just natural log of x. All right. Number 4. All right, let's do another one. F of x equals 3x squared times the natural log of 4x. All right, so again, separate them out. This is my 1, and this is my 2. All right, so whenever there's an x in front, I got to do that product rule. So I need a 1 d2 plus a 2 d1. All right, so 1 is 3x squared, and then 2 is going to be, all right, 4x on the bottom, because that's what's behind the ln, and the derivative of that, which would be 4 on top, plus, all right, 2, which is the natural log of 4x, and then d1, derivative of 3x squared, 6x. Okay, so let's clean it up. All right, so let's see. Obviously, these 4's knock out. And then I have 2 x's on top and 1 on bottom, so one of these x's knocks out. So the only thing I'm left with is a 3x here. Now, be careful. I'm going to say this. You are not allowed to multiply those things together. Okay, natural log of 4x is stuck at the natural log of 4x. So all you can do is whatever's at the end, you can write it at the front. Okay, but that natural log of 4x, and that's why a lot of people put parentheses around whatever's after the natural log so you don't get tempted to multiply anything in there, but be careful with that. Okay, and then number 5 says, gave you a little note, and it says whenever you have an x and a natural log of x and they're divided, you have to use a quotient rule. So we'll do our low d high minus high d low over low squared. All right, so we've got low d high, so I need to the derivative top, so that's going to be x on the bottom and the derivative of that, which would be 1. Low d high minus, all right, high d low. What's the derivative of x? Just a 1 over the low squared. All right, so these x's would cancel. Just leave me with the 1 there, and then it'd be 1 minus, and natural log of x times 1 is just natural log of x over, I should have written the low squared, which would just end up being x squared. All right, 3 terms in that fraction. None of them share anything in common, so I am good to go. There is no reducer. Okay, now the next part relies on your algebra knowledge. Okay, you want to be careful. Let's see. I might add one in here as well. All right, natural log of the square root of x plus 1. Okay, there's going to be a big difference. I'm going to do 6 and I'm going to do 8 at, next to each other. I'll come back and make sure I get 7. All right, so if you're looking at those two, the big difference in those two problems is where the square root is located. This one is not, the natural log is not underneath it, and in this one the natural log is. Okay, so you want to be careful. These are very different problems. All right, so from algebra, as long as that natural log was on the outside, okay, what you could do, okay, was rewrite that. We know square root is a 1/2 power. Okay, and so we learned from algebra, one of our properties when we first learned about logs was that anytime you had that exponent and that natural log was not included in there, what you can do is rewrite it, and you can take that exponent, drop it down to the front. So I'm not writing f prime of x, I'm just rewriting my original problem and getting that 1/2 down to the ground. This makes my problem so much easier to take the derivative of. Now I'm ready to take the derivative. So this looks just like the first one that we did, okay? If you got just a number in front, leave it, okay? But now let's take the derivative of the natural log of x plus 1. So we put x plus 1 on the bottom, and the derivative of that on top, which would be 1. So this time there's no canceling, so if I multiply straight across the top, I get 1. And on the bottom, you can write it like this, or you could distribute that. 2. It really doesn't matter. I'd probably leave it like this, but the second answer is fine as well. Okay, now big difference in number 8 because of where the natural log is located in relation to the square root. When I write it, all of a sudden it's the whole thing to the 1/2 power, not just whatever's after the ln, it's the whole thing. And so when the whole thing is in there, that's a chain rule. We know that. So let's do that chain rule derivative. It'll be 1/2 times the coefficient, which is just 1. Same parenthesis, but drop it to a new power. So when I subtract 1 from a half, I get a negative 1/2 times the derivative of the inside. So derivative of natural log of x would be x on the bottom and a 1 on top of that. All right, so let's think about cleaning this up. Draw me a long fraction bar. I got a 2 on the bottom and I also got an x on the bottom. So let me go ahead and put those on there. Okay. Now we know you can't have negative exponents. So if it's on the top, you know, you move it to the bottom. And let me go ahead and put it back in that square root form. And the only thing that would be left on top is a 1. Okay, so make sure you look at this, rewatch these two, 6 and 8. Make sure you understand the difference. And then number 7 works just like number 6. We'll work the last one in. All right, it is f of x equals the natural log of the cube root of 3x plus 1. So this is an easy one. As long as the natural log is not underneath, it's not a chain rule. So the first thing we're going to do, we're not going to take the derivative. We're going to rewrite it. And so we know a square root is a half power and a cube root is a third power. Okay, and then from algebra, any exponent can go down and drop in front of its natural log. So again, don't take the derivative yet, you're just rewriting. All right, now we're ready for f prime of x. So 1/3 is just going to stay, and let's take our derivative here. So we put whatever's behind the ln on the bottom, and the derivative of that on top. And then what happens with those 3's? Those 2 can cancel out. So my derivative would be 1's left on top, and 3x plus 1 is left on the bottom. All right, go try my math lab.